Cobra's speed advantage enables it to dash ahead and soften up the landing before the troop-carrying helicopters arrive.
So for over 90 years, Bell is really focused on problems that are both challenging and impactful on people's lives. Things like the first U.S. military jet aircraft, the first commercially available helicopter, and the first and only operational tilt rotor in the world.
We first flew tilt rotor technology in 1955 with the XB3, and from there we've had multiple iterations to finally get the V-22 fly-by-wire tilt rotor technology, and lessons learned from that are rolling into the future long-range assault aircraft.
The H-1 changed the way we fight wars. It changed the way that we support our service members when they're injured on the battlefield. Not only that, it provided speed and maneuverability to our ground commanders. The H-1 became the foundation upon which we built a tremendous legacy.
To hover, to soar, to transcend traditional pathways of flight. This is the story of that vision.
Well, our products transform lives in many ways. Search and rescue, emergency medical. The 412 is a fantastic firefighting aircraft. We have a tremendous number of customers that use that to battle wildfires. And that's what's great about our products. They get up and go to work every day.
Helicopters are incredibly complex vehicles. Most recently, a lot of our focus has been on making helicopters more accessible through affordability and availability. The people that matter are the people in the back, whether those are patients, whether those are troops, whether those are workers, and to get them where they're going safely or to rescue them from a dangerous situation.
So I think at Bell's core, we are innovators. What you're seeing is not just a constant evolution of technology, but also a revolution of technology as we've made some pretty significant leaps with fly-by-wire, with MOSA, with tilt rotor technology, and we're going to continue to do that. A clean sheet design is something that didn't exist before. We might pull elements from our experience, pull elements from technology development efforts and innovations that have been going on in parallel. The future long-range assault aircraft, the V-280 Valor, the 525, these clean sheet designs that are our opportunity to get engineers in the room with a set of requirements and understand how will I address those requirements. And ultimately, it comes down to the grit and the tenacity of folks, engineers and software developers and pilots and manufacturers and everybody else to get something from that clean sheet to a flying product.
My favorite aircraft is absolutely the 525. It's the first clean sheet design that we've done in a very long time. Most of our products are what you would consider derivatives of a prior product. Even, the 412 is a derivative of what the H1 was many years ago. For the 525, it was an opportunity to start fresh, take all the lessons we've learned over generations, both on the military and the commercial side, and integrate it into one amazing solution for our customers.
So we are working on emerging technologies through our advanced programs team. One is aircraft autonomy, so we have a flying lab that's a Bell twin-engine 429 that we can fly autonomously from the left seat, that we can use to quickly evolve and demonstrate perception systems, autonomous landing zones, things like that.
When I think about autonomy and aircraft autonomy, we see a lot and hear a lot with drones, but it's different when you're flying people, right? And when you're talking about the future long-range assault aircraft and you're talking about a crew and soldiers in the back of the aircraft, really I think the key is having a sliding scale of autonomy. The future long-range assault aircraft is really the Army's Black Hawk replacement. And so it is a air assault capability that can go twice as far and twice as fast and incorporate a modular open systems approach to its architecture for its mission systems. So with the application of fly-by-wire technology, we were able to demonstrate in the V-280 Valor Joint Technology Demonstrator the capability to fly autonomously and give the operator and the customer the flexibility to decide how much autonomy do they want.
In its production, the Bell Aircraft Corporation has pioneered in a new type aircraft which is certain to be closely allied with the expanding frontiers of aviation. This is the X-1A.
Our employees are absolutely the thing that drives innovation here at Bell. We have incredibly smart individuals at this company, all the way from the shop floor to really every part of our business, including our pilots.
We've got a diverse set of employees. Some have worked in emergency medical services. Each of them brings something different, and it's all valued.
Really, the employees are the lifeblood of our innovation.
The most important thing for us is to inspire people to connect to the idea of flight. Most of the people here have not even been in a helicopter. I love the idea of getting people to connect more to what we do. We're doing that through several initiatives, through high school internships, college internships, co-op programs. One of my favorites is our advanced vertical robotics competition, where we give a drone kit that's fairly advanced to high school students. At the end of the competition, whether your aircraft can fly, whether it can pick up the obstacles, whether it can complete the mission or not, is a direct reflection of the work that you put into it.
The dream. To fly without boundaries.
I think when you look at what drives Bell and what drives our employees, we want aircraft to be safer. We want to be more reliable and maintainable and to be able to do things like go twice as fast and twice as far. MOSA, or the Modular Open Systems approach, is really core to what we're doing as we're developing the next generation Army aircraft. It's really standardizing, how we integrate various systems and making information and intellectual property and data rights available to ultimately the customer. It is going to really give them the keys in the future to continuously be able to upgrade their platforms like they've never been able to do before. We've got other things in the work with high-speed VTOL, or vertical takeoff and landing systems.
We're also working with agencies like DARPA to work on next-generation aircraft capabilities, like our high-speed VTOL stop-fold aircraft, which combines the hover capability of a rotorcraft with the speed and efficiency of jet mode flight.
Well, the 525 is a step change in capability for our commercial platform customers. It will be the first certified fly-by-wire commercial rotorcraft when it does reach the market. The 525 has a very robust system there, integrated vehicle health monitoring system that helps our operators use predictive analytical tools to maintain their aircraft before it is down for service. So it enables our customers to schedule maintenance around their operations instead of scheduling their operations around the maintenance.
We want to keep advancing, and we want to be providing capabilities far beyond what we were able to provide, with technology a couple decades ago. So we're excited about that. We're not giving up and stopping here. So that excites us, and we're going to keep doing it in the future.